Hi, I'm excited to talk with you today about using Docker with Web3. Let's dive in. I'm JT, I'm the CTO at Storj. Storj is a decentralized storage provider. We deliver enterprise-grade S3 backwards compatible object storage across a global network of independently owned and operated storage nodes. Naturally, Docker was a big part of how we've built storage, but more importantly, we think it will continue to be an important part of how decentralized systems such as ours are built. We'll also be hearing from Marton, one of our principal software engineers at Storj, and Krista, the head of infrastructure at Storj. Let's step back for a minute and talk about what are we even talking about when we say Web3. If you were online around the time that we call Web 1, you might remember it as a largely static collection of personal web pages, maybe academic web pages. It was pretty uncommercialized. Maybe there was a GeoCities in there, but for the most part, it was pretty quirky. Lots of good content, but didn't really know what the internet was going to look like yet. The term Web 2 came around. It was largely to talk about the read-write web. And people were excited by the opportunity of building platforms and applications that users could interact with and contribute to and be able to share and distribute their own content on top of these platforms. So that's great. It also became extremely commercialized and has a concerning amount of data mining that's a part of it. So there was the hope of Web 2, and then the sort of the reality of Web 2 around some of the outcomes that we're now dealing with and people are making Netflix documentaries about. And so the question with Web 3 is, what is it? Is that this? There's a lot of noise. There's a lot of hype. Is there anything here? Is there anything useful with Web 3? So let's try and look just quickly at sort of what a standard Web 3 application sort of looks like. The Web 3 tech stack often has peer-to-peer communication, has strong encryption, might have a portable execution framework, such as containers or WebAssembly or the Ethereum VM. There's often some content address storage routing, IPFS. That's kind of just the shape overall. There's often a big emphasis on low or zero trust environments. And there are sometimes blockchains, though not always. IPFS, for example, which we'll talk about in a little bit, doesn't have any blockchain. We think the thing that will define Web3 in a way that outlives being a flash in the pan is being ruthlessly focused on what is useful to users. And so the things that benefit users, we think, are a collection of things, but strong encryption provides a level of security. End-to-end encryption, client-side encryption is much better than trusting some central provider with your private data, which leads us into privacy. How can you control your activities and your action online in a way that you're benefiting from, but not someone else? Reducing the need for central trust just in general. Privacy, of course, is one angle, but there are many other angles in which central trust has often been abused, and we're a little sick of it. Finding alternate funding besides ads. It'd be great to be able to fund the internet without some of these negative influences on what is the internet and what is it for. Some Web3 projects are very interested in new and innovative ways for self-government and transparency. And frankly, there is an ideology of taking back the web for the users, taking it away from this kind of oligopoly that's formed. So it's the Wild West. There are shady actors, and it's still a battle for what the web will be. But these things are good things. And I think these things, are potentially worth fighting for. We think decentralization provides these things. We think decentralization is the key ingredient that, sort of across all of these ideas brings many of these user focused deliverables to light. And so we think Web3 can offer the benefits of decentralization to developers today. There's a great blog post by Tim O'Reilly about how when there are periods of hype, often a lot of funding is laid down for infrastructure. And that infrastructure ends up propelling kind of the next level of innovation. I think that's kind of interesting. There's a lot of infrastructure that's been built for Web3 already, and it might be useful to your app today. The Web3 infrastructure that exists and is usable. And so we're really excited to just sort of share what the on-ramps are for Web3 that are available and active and you can use with familiar tools. So for that purpose, I'm going to turn the time now over to Marton to talk a little bit more about the Docker container decentralization on-ramp space.
Thank you, JT. So until now, we talked about Web3 beyond the hype, but the current question is that what is the connection between Docker and Web3? How can we use them together? And first, they seem to be very, very different technologies, but in fact, I think they are very close to each other because the innovation of the Docker containers is exactly the same. It started to provide better usability for the users, for real user demand, using existing technologies like Linux namespace isolations and cgroups. And this is exactly what we have in the Web3 space as well. We have real user demand for better privacy, security control, and so on. And we have some new technologies to use. So to understand how can we use them together, first we need to check the Web3 space or decentralization space, that what kind of projects can be found there. But just describing the full decentralized landscape, it's not very easy. You remember that the CNCF started to create different landscape pictures, but after a while it became so complex, so it was a universe, not a landscape anymore. And exactly the same is true for the decentralized landscape. It's almost impossible to mention all of even just the big projects or even just the categories. We have so many decentralized solutions in finance, governance, social ops, messaging, so on. So one question is, why do we have so many different decentralized applications? And I think there are multiple answers for this question. One is that it's not new at all, right? Email is a decentralized application. The federation is a form of decentralization. So it's very, very old. So we have a lot of application. The other important thing is that since Bitcoin, the number of decentralized applications, especially the finance application, is boosted. Because before Bitcoin, nobody believed that some financial projects can be implemented in a really decentralized way. But Bitcoin showed how is it possible. And after that, a lot of new projects created. Just, why not? Let's try it out. And unfortunately, it also created a lot of projects which may less value, and the goal was just to get more money, not to create to address the user demands. So skepticism is warranted, but also cautious optimism. It can be really useful for the users. So instead of checking all of the decentralized landscape, we will start with the storage. There are two main reasons for this one. First of all, the storage is really the cornerstone of a modern big application. We need to store the data anyway, right? The other one is that the two lines here, which are connected very well to the Docker, this is the cloud computing part and the storage. There are interesting projects in the cloud computing as well, like the Akash, but we will start with the storage because it's already a very big space for projects. Okay, so let's talk about the storage. We already had a lot of storage solutions, different kind of distributed systems to store the data, and usually it's very well known that it's not very easy to create a distributed systems. And when we are talking about decentralized systems, it's even harder because it's not enough that the component should agree the components have a consensus in a specific about a specific state, but we need to address the problem that some component may be bad, and we need to filter out the malicious participants. And when we are talking about the storage, it's even harder. That's level 3, right? Because this is something like a game with only one life. If data loss, that's game over. If the execution is bad, then we can just restart it. But for storage, there is no space for errors. Okay, so let's talk about the typical storage problem. And usually what we do is just we store somewhere in the metadata of a file or key or something, and we should store somewhere the data, the real bytes, right? And usually we store the data at more than one space. Just we need to replicate it just to be sure that we have. And especially if it's a decentralized landscape, we need to encrypt all of the pieces just to be sure that we can read it, or the user read it. So the differences between the reason why we have so big differences between the storage projects or decentralized storage projects, because there are multiple answers for these questions. How can we store the metadata? Well, we can store it on some kind of blockchain, which might be harder to scale those solutions. But after that, there is a very clear single truth of the source. There is another approach what storage follows. This is the federation, which is something like the email, that instead of one blockchain, there are a lot of smaller components which can talk with each other. And we have the same question for the data, that how should we store the data? So there are less projects. So usually other decentralized projects store the metadata on the blockchain, but Airwave, for example, also stores the data on the blockchain itself with some trick to address the hard problems that, okay, in that case, the chain will be very hard. And there are other big questions like, okay, that how can we manage the nodes? How can we be sure that the nodes are really store the data which are assigned to them? Okay, so storage follows a simple way. We have data nodes which are run by volunteers. Storage Labs itself doesn't run any data nodes. So all of the data is stored by volunteers with free space on Raspberry Pi or servers. And the Storage Labs itself operates the federated metadata services, but the goal is just to make it easier for community members to run the similar metadata services. And it's very important that storage also operates some kind of bridges to make it easier to use, right? The usability is very important in this space as well, to easier to use the decentralized storage for the users. Okay, so it seems that we have some connection between the Web3 and Docker. So the next question is, how can we really use them together? And we will check 6 use cases where we use decentralized storage from Docker. And we can categorize these use cases to 2 groups. One is that when we use the decentralized storage from the infrastructure layer, like pulling the images from there. The other one is that when we use decentralized storage from a Dockerized or containerized environment, but it is some storage for the users under the hood, which may or may not be visible for the users. And in each category, we have different approaches. This is what we will check one by one. The first is when for the users, right? The user would like to use decentralized storage from some containers application. That is not very easy because we need to update one by one all of the applications. But for example, the Nextcloud, which is a self-hosted cloud service, we already supports the storage backend there. So this is just a screenshot where you can mount the decentralized storage in Nextcloud. And it requires to create new Docker images. So the goal is to add decentralized storage support to the main core Docker images. If we are talking about the native support of the infrastructure level, like Docker pull directly from decentralized storage, unfortunately, this is way harder. And there are different type of attempts, like creating container plugin. There is a working progress pull request, or client-side resolver parser. So in programmatic level, there are multiple approaches. Unfortunately, none of them work out of the box right now. So what can we do? And here we can create bridges, right? Just to make it easier for the users to use the projects. So one approach is that, for example, net control has a net control IPFS command, which runs a local Docker registry. And after that, the Docker pull and push works out of the box. So IPFS is a data routing protocol. That's one reason why we didn't mention it earlier, because it's slightly different. It doesn't really talks about how the storage is supposed to be stored on the specific nodes. It talks about the way how the data can be found. Okay, and this is an approach when we have a local bridge, just to start it and make it easier to access the data. The same thing can be done for the users, right? If the storage can provide, or the decentralized storage can provide a SRE compatible bridge, it can be used from sidecar containers. It can be mounted in a fuse drawer. This is the previous example, and as we see here, it's very easy to start a local SRE bridge instead of running the shared bridge. But we have shared bridges because we would like to make it even easier, right? It's slightly complex to start some local bridge. So in the next two demos, Krista will show that how storage provides bridges for both for the users to, for example, mount an S3 bucket, and both for the infrastructure, like pushing, pulling Docker image for decentralized storage, with the help of already existing bridge, or with the help of hosted bridges, which are provided by the storage itself, but it's not a strong dependency, so it can work with local bridges and later with native support.
Thanks, Marton. For this demo, we'll be looking at how you can use a native integration to bring decentralized storage to an application you're probably all familiar with already, the Docker Registry. We've used the Storj DCS native uplink library to implement the storage interface within the registry. For simplicity in this demo, I'll be launching the registry locally. And yes, the credentials you see in this demo have already been revoked. Let's take a look at the configuration options that we've added to the Docker Registry. As you can see, we've added a storage section, which allows you to specify the use of Storj DCS for the backend storage for your registry. It takes in an access grant, as well as the bucket in which you wish to store your blobs in. Next thing we're going to do is we're going to launch the registry. And then we're going to pull down the latest Alpine image. Let's go ahead and tag that image with our registry, which I've already added to the insecure registries within my Docker daemon. And let's push up that image to our registry. Some of these error messages are the 404s because the image hasn't been pushed yet. We're dealing with a completely fresh registry here. And you can see here that the layers are all being pushed up. And we're done. So now what we're going to do is we're going to use a tool called Uplink. Uplink is a CLI tool that allows you to interact with Storj DCS buckets. We're going to use this tool today just to verify that everything is in the registry that we expect it to be and explore the file structure a little bit. So here you can see we're currently listing the Alpine repositories, and you can see that we've got that one there. We've got our layers and our manifests. And then what we're going to do now is we're going to take a look at the tags directory. And we can see we've got our DockerCon 2022 tag. So just to summarize, we've demonstrated using a standard application that you're all very familiar with, but using decentralized storage to store all of the data that this application creates. For this second demo, we'll be looking at how you can mount a Storj CCS bucket as a directory in a container running within Kubernetes. For this, we'll be using the small example of backing up a Postgres database using the pgdump command and having that database backup being automatically pushed into Storj DCS. In order to mount the DCS bucket within the Kubernetes container, we're going to be using the S3 container storage interface created by Ctrox. For this demo, I've primarily followed the examples in their README, but done some changes in order to make it point to our managed gateway as opposed to an S3 endpoint. As you can see here, we have a mounter specified, which is specified as the rclone mounter. Now, the reason that I'm using rclone in this example is because it seems to have better compatibility with POSIX functions like move and copy. Additionally, we're specifying the bucket that we want to use within DCS. Next, let's take a look at the very small backup script that we're going to be running. So as you can see here, we're doing a pgdump of the database. And all we're going to do is we're just going to copy it into that mount directory. Now, if we take a look at the actual job, you can see here that we're going to run this once a minute, which is a little intense. And we've specified here our PG host as the internal DNS entry that we have for that Postgres container, as well as our mount point here. And we're volume mounting in that persistence volume claim that's coming from the container storage interface. Let's go ahead and apply the base Kubernetes resources. And the primary pieces here are the CSI attacher, the CSI provisioner, and the actual CSI S3 application that's running. Now let's go ahead and apply our example application. Next thing I'm going to do is we're going to actually tail the Kubernetes events that are happening. And you can see here that the volume, the PVC volume, has been successfully provisioned using the S3 container storage interface. Additionally, here we can see that our Postgres backup cron job is starting to spin up. And if we check, we can see that the container is creating. So now that we have that container created and the job has started, we can take a look at the logs and just make sure that everything is running accordingly. So here we've done the pgdump successfully and we've moved the file. And this is just executing that sleep command that you saw within the backup script. Now let's go ahead and use the uplink command that we saw earlier in order to inspect the contents of this Storj DCS bucket. So as you can see here, we have our latest backup, which was successfully pushed into the DCS bucket via that mount point. In conclusion, you can see that it's very easy to start using decentralized storage with applications that you're already familiar with, whether that be via our gateway bridges or via native uplink integrations. Thank you.
Thank you, Krista, for those shared bridge demos, and thank you to Marton for putting them into context of the wider universe of ways in which decentralized storage can be added to existing or new projects. We're excited to see what you build. We're excited to see how you can provide the benefits of decentralization to our end users and your end users. If you'd like to learn more about some of the stuff that we've talked about in this presentation, we've prepared this link, this bit.ly storage Docker Web3 URL will have some links to some things that we mentioned, such as pull requests that we've referenced, some example configs, and a couple of other references around how you can get started with Web3, Docker, and maybe storage. Thanks for your time today.